Okay, Bismillahirrahmanirrahim. This was the slide on which we started previously, and we were talking about abstraction. And in abstraction, we already have seen the abstract class somewhere, but anyhow, this is also an example 3. In previously, it was example 2, so this is example 3 of that abstract class. And in this example, you will see some abstract class, and then there is some other class which is extending that subclass. Then there is third class which is extending the same abstract class, and then we have the normal class with main method. So this class, the name of this class is bank. Now the keyword is abstract there, so this is abstract class. This is the way how you can write an abstract class. So abstract class bank, starting, ending. What happened, Ismail? I only have 10 or 11 students in this class, and if you are sleeping. We have from 11 to 4. Okay. So this is the, just a minute. If I will talk and become a machine again, huh? So this is the abstract class. The name of this class is bank, and due to this abstract keyword, it is abstract. An abstract class can have the abstract methods. So this is the get rate of interest is abstract method. How I can identify the due to this keyword abstract. And this method is returning some value, which is integer. Okay. If this is an abstract method, that method will have its implementation or body in some other class. So there is a class SBI, which is extending this bank class. And here we have the body for this method. And int get rate of interest, these are the empty parentheses, which means that it is not taking any argument. But this int means that this method will return something. So that's why within the curly brackets, we have this statement return 7. And this method is only returning this value 7, nothing else. There is no any further detail available in this method. This is a simple program to give you the understanding that we can inherit classes with this abstract class. Then we have another class, P and B, extending again this same bank class. And we have the get rate of interest, same method, returning only 8. Okay, then we have the fourth class. The name of this class is test bank, and this is a normal class, normal simple class, starting here, ending here, and we have the main method starting here, also ending here. And in this main method, first we are creating an object, bank B. This B is a name of an object which has the type B, which has the type bank. And bank is a parent abstract class. Parent but abstract class. Okay, then what? B is equal to new SBI. So right hand side is different. This is what we are doing in all these things. So this circle is a child class, but this shape is a parent class. And here the left hand side is different. This is what we are doing previously. So here B is equal to new SBI. So right side is the reference of the child class, and B is the object, which is this bank type, which is parent. And then what? System.out.println rate of interest is plus B dot get rate of interest. So we are calling this method get rate of interest through this object B, and B has a type what? Bank. So I will go first into the bank. I will find this get rate of interest there. Okay, okay, it is found there. But this is the abstract method, does not have the body. So where I can find the body, the compiler will see the right hand side. Due to that reference of right hand side, I will go then into the SBI class. This is SBI class, and I will execute this method. I will find first method. I will find this method there, and then I will execute it because we have the body here. And the body will be executed. This is the only one statement available here. And it is returning what? It is returning this value 7. 7 is an integer. Okay, so here you will have the 7 that will be returned here. So the rate of interest is 7, and then this percent will be displayed, which you are seeing in the output. And same is for this P. B is equal to new PNB. It is for this class, and this method will be called, value will be returned, and you can see the output. I have skipped this second portion because it is the same like SPI, and you can read it and understand it by yourself. Now, now we will see some examples in which our abstract class will have the constructor, also will have some data members or the methods. In other words, if you are going to write an abstract class, then you can write the fields, which are the data members. You can introduce the fields into an abstract class. You can introduce abstract method in an abstract class. That is already we are doing. We can introduce non-abstract methods in the class also. That is a new thing that you have learned. You can introduce constructors in the abstract class. Even you can introduce the main method in the class because it is non-abstract. So this is the additional information. So let's have a look over it. So for example, but there are some rules here. If in a class you are going to write an abstract, you are going to declare an abstract method. For example, this run return type void, and it is abstract due to this keyword. But class is not abstract, then this is not okay. Okay, then you must have to either make this class abstract, otherwise it is a compile time error. Or if you want to remove that error, then you must have to make this class abstract, or you have to make this method non-abstract, then it will work. Anyhow, let's have a look over this example. Now we have a class, abstract class is bike, starting here, ending here. So this bike abstract class, this is a constructor because it has the same name as the name of the class. And this abstract void run, this is a method which is abstract method. And this constructor has one message in it, which we will print through this system.out println, bike is created. Okay. And this method run is abstract method. It means that the body of this method would be somewhere else in some other class. And then we have a normal method, which is non-abstract method. And the name of that method is change gear. And it is printing only one message, gear change. This is the end of that abstract class. And then we have class Honda, extends. Extend is for inheritance. Extends bike. So now this bike will become the parent and this Honda will become the child. And this is the implementation of that abstract method. Abstract method was run. And this is the body of implementation of that run method. And it is printing only running safely, just single message. And here this is a class in which we have the main method which will control the whole program. And this is the main method, okay, bike, obj is equal to new Honda. So the right hand side is that child class. Left hand side is that parent class, according to our previous practice. This is the previous practice which we are doing here. Okay. And then here obj.run. Obj has the type bike. So I will go first into the bike class and I will find this run there. That run is available as an abstract method here. And if it is available and abstract, where it is body, because body has to execute this. This only one statement is insufficient. So according to the right hand side of this object obj, I will go then again to what? In Honda class. And I will find the body of this run method which is available there. But Sorry, one thing I should have to mention. When we created this object, bike obj is equal to new Honda. When you created this object, you know that if you have constructor or default constructor available in your class, what is the timing of that constructor to execute? What is its timing? Its timing would be when you create an object of that class. Then constructor will be executed. If you have default constructor available in your class, that default constructor will be executed at what time? When you will create an object for that class. So here, when you are creating an object for that class, bike obj new Honda, so here you are actually calling, if here we don't have the default constructor for this child class Honda, it is not mentioned there. But what will happen? Compiler will add that default constructor into it by itself. You are not writing it, but when you will run your program, first step is compilation, second step is running. During compilation, that default constructor will be inserted by the compiler into your program. So it means that default constructor with name Honda is also available here in this Honda. So that default constructor will be executed. But that is a default constructor. It will not display anything. It will not update anything. Except if you have fields in your class, the values of those fields will be initiated with null values. So anyhow, default constructor will be called. And that is a child class of some parent class. So when default constructor of child class is executed, the default constructor of the parent class will also be executed by your, when you will run your program. And here your constructor, default constructor is available. What is default constructor? Constructor without arguments. And it is without arguments. And you have one statement written there. So when your program, when this statement will be executed, the right hand side especially, this will be called indirectly. First, it will go into the child class. It will execute the default constructor there. Then it will go to the parent class of that child class. It will go, if the default constructor is available there, it will execute it. So that's why bike is created will be displayed first, because due to this statement. And then after that, obj.run. Okay, I will go into the bike first. I will find the run there. Run is abstract method. Where I can find the body, go into that class in which that body is available. Where it is available, according to previous information, due to this right hand side, I will go into that Honda. I will find the run method there, and it will print this running safely there. It will be executed, and this only one message will be displayed on the screen. And then what? Okay, and then obj.change gear. So obj has a type bike. So I will go first into the bike, and I will find the change gear. Change gear is non-abstract method. So non-abstract methods of a parent class can be called with object like that, which has the right hand side as a child class and left hand side as a parent class. If you have the object like that, then non-abstract methods of the parent class can be called. You will not have any compile time error. Maybe if you have that message away here, maybe you will have some error here. But if you have that thing available there, because we said here. But with new versions of Java, things are changing and they are allowing different things which are not allowed in the previous versions. So change gear. So this will be executed, and system.out.println gear change will be displayed on the screen. So here in this example, we saw that we are using constructor in abstract class. We are using non-abstract methods in the class. We can also, and this is the abstract method according to previous practice. Now, we have another situation. We can design an interface, and then we can have an abstract class which will inherit this interface. if your class is going to inherit, if your interface is becoming a parent and your class is child, then you cannot use the word extends here. Then you have to use this word implements. We will see this example later on when we will have that information, or sorry, when we will study something about interfaces, then we will come to this example again. Up to that time, we are leaving this example because this example is available again at the end of the, yeah, this is the same example, okay? Because now at the end you will have the information of an interface, then we will see that example again. So at the moment, we are just leaving that example just to save our time and moving next. Interfaces in Java. What is interface? So now we have the information about abstract classes. But what is interface? Previously, we saw that interface is something which will provide us the abstraction 100%. Abstract class will provide us abstraction from 0 to 100%. It can vary from 0 to 100%. But interface will provide us 100% abstraction. So interface is what? Where is the pen? So interface, yes, interface is a something to achieve abstraction. Okay, this is what we know. And in the interface, if you will introduce methods, those methods would be abstract only. Okay. It is written here that there can be only abstract methods in Java interface. It means that in interface, we can only introduce abstract methods. We cannot introduce non-abstract methods or anything else. Okay, up to this point, that is the definition. But maybe it will change because in new versions, things are allowed. Non-abstract methods are also allowed in the interface. Anyhow, up to now, if we will introduce some method in the interface, that method would be abstract. That method would be abstract. What is abstract method? It means that that method will not have the implementation. That method will not have the body. And we use interface. One point is to achieve abstraction, another point is to achieve multiple inheritance. Multiple inheritance and hybrid inheritance is not supported in Java classes. This is what we said in CO inheritance. And there we studied maybe 5 different types of inheritance. 3 are valid, 2 are not valid. This is what we said there. So multiple inheritance and hybrid inheritance, which was not allowed in classes of Java. Now that multiple inheritance and hybrid inheritance is allowed in interfaces. You can achieve that multiple inheritance. What is multiple inheritance? One child, multiple parents. Okay. One child which will have multiple parents and also the levels like tree. So multiple inheritance that was not allowed in classes, now allowed in interfaces. It can have constants variables. Constants means constants variables. You will see, for example, public final or public static final int max is equal to 5. So this max is a variable which is now constant. You cannot change the value of this variable into your program. So you can declare constants, static constants in it, or abstract methods, okay? Is a relationship. Maybe you will not understand it because in chapter 1, we removed some of the content. I don't know, maybe from chapter 1 or from chapter 2. That was about composition, aggregation, or like that. So that term is related to that thing. Okay, so leave it. It cannot be instantiated like the abstract classes. For example, for abstract class, you can create an object like you are creating in previous examples. Here, for an abstract class, obj has the type bike. When we studied this, when we started this abstract class, we said that you cannot instantiate an abstract class. But here we are instantiating, but not on the right hand side, okay? Right hand side is actually important. We are just creating an object, just taking reference of the child class. Actually, this is the child class, Honda class. This object is the object of Honda class. But we are just using the data type. We are not actually creating. It would be actually, if it would be like bike, obj, new bike, parenthesis, semicolon. That would be. But this is, we cannot do for abstract class. Same is the case here for the interfaces. We cannot instantiate like the abstract classes. But previously, the left-hand side, you are writing that abstract class. For interface, maybe we have that same method or some other method. Let's see what we'll have. That would be different. Why use Java interfaces? To achieve abstraction, one thing. To achieve multiple inheritance, another thing. To achieve loose coupling, third thing. Loose coupling means dependency. This is also the concept that was in chapter 1, which I removed from your slides because that is, I told you that is not object-oriented programming. That is something I can include and I cannot. So that's why I moved. Loose coupling means that, for example, in one organization, if one department is dependent to other, that is not loose coupling. That is strong coupling, you can say. If two departments are dependent on each other but weakly, then that is called, for example, if one department dies, the other department will live. The other department will not die. So this situation, in this situation, when one department will die, other will live, then this is called a loose coupling. But if one department die, other also die, then this is strong coupling. So interface has these three main uses. How can you write interface in Java? So, okay, you will have to use the keyword interface, and then you can write the name of the interface, then starting bracket, ending bracket, and you don't have any kind of parenthesis. It is very much similar to your class. So interface, and then the name of the interface, starting bracket, ending bracket. So similar to class. And then you can declare fields here in, like fields in class. Fields mean, what is the meaning of fields here? Instance variables. So the variable like int, double, long, whatever it is, string, the variables that you will declare here, that would be called fields. These variables you can declare in the classes also. So, but in interfaces, you can declare fields, but those would be constant by default. If you will declare, compiler will automatically make them constant. If you will mention it by yourself, that's good. If you will not, compiler will do it automatically when you will run your program. If you will write methods in it, those methods would be abstract by default. If you will write them as an abstract method, that is good. If not, compiler will automatically do it. It will make your methods abstract automatically. So that's why in the interfaces, you have the method, whatever the methods you have, that would be abstract. This is what different things are mentioned here. And now you can see here, if this is your interface and this is the name of the interface, this is starting bracket, ending bracket. If you have some variable in it, integer, main is equal to 5, and if you have some method in it, and the name of the method is print, return type is void. If you will not write anything, in interface, all the methods are by default abstract methods. And all the fields in interface are by default constant. Constant. If you do it, it's good. If you will not do it, compiler will automatically do it. How? If this printable.java is your program, when you will run it, first step is compiler. It will add these things with the variable, and it will add these things with the method, with the method name. And what it is adding? Public static final. When you have static and final with the variable name, int min, then this min is now becoming constant. It is now constant. You cannot change the value of this min variable. If you will give 10 to this min variable, you will have the compilation error. You are not allowed to change the value of this variable. And this print is a method. Now it is an abstract method. It means that it will not have the body here. The body will be somewhere else in other class. Okay. Relation between classes and interfaces. Previously, if you have a class, some parent class, and if you have the child class will use the word extends to become a child of that parent class. But if you have the interface, you want to make some interface, a parent of some class, then you can use the words implements. This extend will not work here. If you have, if class is your child and interface is your parent, this is what you want. You want to make some interface a parent and class as child, then you have to use the word implements with the class. And similarly, if you have two interfaces and you want to make one interface the parent, other interface the child, if both are same, then you can use this word extends. So you can say that if the parent and child is same, then we are using word extend. But if the parent is interface and child is class, we are using the word implement. This is the relation between classes and interfaces. Now we have some small example. Interface example now. Here first we have the interface, and then we have the class which is implementing that interface. So this interface is becoming parent, and this class is child. And that class will go on and it will end at the here. So how we can write interface? Okay, write the keyword interface. Name of the interface is printable, starting, ending, and we have only one method in it, and we are writing void print. So this method is now, what type of method it is? This is the return type. No, I am saying that this is, we have only one method here. So it is without body. So it is what? Abstract. In interfaces, if you will not write abstract, no issue. That is automatically abstract. By default, it is abstract. So this print method, which is written in this interface, by default, it is abstract. Either you will write abstract before it or not, no issue. The compiler will do automatically, and it is abstract method. And if it is abstract method, its body or its implementation must be somewhere else in some other class. So that's why we have another class A6, and this is the class, and the parent is interface. So that's why we are using the word implements. Implements printable. This is the name of that interface. Starting here, and here it is the body of that abstract method. Void print and system.out.println and printing just hello. We have the main method in this class starting here, now creating an object of this A6 class. Obj has the type A6, new A6, so left hand side and right hand side is same. So the most easiest form of object creation. So this is an object now for this class A6. and I can access whatever available in this class A6 through this object. So obj.print. So this is the type obj has. What is the type of this obj? A6. So I will go into this A6 and find the print. It is there, and it is just printing hello. So hello will be printed, nothing else. But this is the first example of interface behaving as parent and child as the class. Now, Java interface example, drawable. So here in this interface, we have again the interface, then we have a child class implementing this interface, then we have another class circle implementing this interface, and then we have the simple class with main method. So this interface, in name of this interface is drawable, starting, ending, and here we have the void draw. So this is the method. This is the method. What type of method it is? Abstract. And now we have the class rectangle, which is implementing this drawable because it is interface. Drawable is an interface, so that's why we are using this word implements. Starting, ending, and this is the body of this abstract method. Draw system.out.println drawing rectangle. We are giving this message because the class is rectangle. Otherwise, you can write anything else. And then we have another class. The name of class is circle, implements this drawable, and it has the body of this abstract method again, and it is printing drawing circle. And then we have the class test interface 1 main method, and here let's see it. So drawable D, so this D is an object, drawable is an interface, and is equal to new circle. So now you can say that you can also use the interface also on the left hand side, not on the right hand side. Not on the right side. So it means that you cannot instantiate an interface. When you have this sentence, you cannot instantiate an interface. It means you cannot create an object of the interface. But this is what you can do. You can use some right hand, some child class on the right hand side, and you can make that reference into that object which will have the type of parent, and if that parent is interface, then it's okay. So it's a very much similar to the practice that you are already doing in these previous slides. So drawable day, new circle. So d.draw. So this d is what? D is an object. So I will go first into the first go into this drawable. And when I will find the draw, this method draw. The draw is there. And the object of this right hand due to that right hand side, then I will go into the circle class. And I will find the body of that draw, which is there, and system.out drawing circle will be printed. Another example of bank. Here we have interface bank, starting, ending. Can you do it by yourself? Because it is again the same thing, nothing different. So interface, and then we have a class SBI implementing this interface, class PNB implementing this interface, and then you have a class with main method, nothing else. Can you do it by yourself? How it is complicated? Okay, let's see. In the interface bank, you have this method rate of interest, which is returning some float value. And here the SBI implements bank. Okay, I'm going directly to this main method. And bank B new SBI. So the right hand side is the SBI and B is the object which has the type bank. So system.out.println ROI, this will be printed as it is because it is a string. B dot rate of interest. B has the type bank, so I will go into the bank first and I will find this method rate of interest there, which is available there, but it is abstract. Body is not available there. Where I can find the body? I can find the body by looking at the right hand side of that object because that is the reference in it. So I will go into that SBI and rate of interest is there. I will execute it, return 19.15 F. F is for float. So that's why that will be matched with this return type of that method. So no issue. So 9.15 will be returned here. That will be displayed. Nothing else. What is complexity here? This is what I told you. You cannot do that because that is interface. Interface cannot be instantiated. If you will do that, you will have the compilation error. Okay. Okay. Here, when we were studying, it cannot be instantiated. It is written there. What it means? It means you cannot create an object for it. Okay. Multiple inheritance. Just a minute. I want to see something. Multiple inheritance in Java. What is multiple inheritance? When a child has multiple parents, this class is now child. When a child has multiple parents, then it is called multiple inheritance. And here we have class as a child and interfaces as parents. So that's why we are using implements words. That is something we already saw in some slide here, where you used implement, where you use extends. And here, if your child is interface and okay, more than one parents, so that is more than one parents is multiple inheritance. Now, this is an example of that multiple inheritance using interfaces. So interface name, so this is one interface. The name of that interface is printable and it has print method in it. There is another interface, name of that is showable and the show method is available there. It is abstract method. Body would be somewhere else. And then we have the class A7 implementing. So here a child can have multiple parents. Okay, you can go. Class A7 implements printable and showable. This is the first example now. Before that, it was not here. It was not in any slide, okay? You can implement, you can inherit multiple parents and those parent classes are interfaces. You can, in classes, it is not allowed, okay? In classes, this is not allowed, but only in interfaces, multiple parents are allowed and then you can separate them with comma. Here, printable is the name of that interface, showable is the name of that interface, and both are now becoming the parent of this child. Class A7. Class is A7. This is the starting, this is the ending of that class. And first, we are providing the body of these abstract methods, which are available in these parents. So print, this is the body, starting bracket, ending bracket, system.out print, just printing hello message. This is the print. This is the body of that abstract method. and show with this welcome message. This is the body of that show message. And then we have the main method, and here we are creating an object A7 obj new A7. Left hand side and right hand side is same. This is the normal object. So normal object means that through this object I can access all the information which is available in this class A7. So obj.print, okay, I will go directly into this class A7 and I will find the print, system.print hello, okay. Hello, that will be printed. And obj.show, obj has the type A7, go to A7, find show, that message will be printed. Now I will not go here into the interfaces and I will check that this print is abstract. That will be checked in the first step of compilation. That this print is an abstract method and its body is available there in that class. That will be checked already in the first step of compilation. But during running now it is not checked. It will not be checked. And now in this example, you have multiple parents and you don't have any compilation error. Before that in classes, it was an error. Okay, make them classes and don't make them interfaces, and then do the same thing. You will have the compile time error here. But for interfaces, it is allowed. I will start inshallah in the next class here. I have to complete it. Huh? The other way around is that I will record this lecture and I will share it on the group. Where you want to go on that day?
We want to revise because I have Sunday I have the database, Monday I have the ecosystem.
So that timing on that day is mine. Where are you going? It is written in the timetable, eh? So it's up to you. You can absent. You may absent in the upcoming class. The other thing is, I will record the lecture. I will record the remaining slides. Maybe it will take 30-40 minutes to me at home. And then I will upload the lecture. Is it okay for you? And the next class will be free. That is okay. I know that. That is okay. I know that timing is short, but if you have to achieve something, don't worry, just go in that direction until you get it. And then you will get it. This is the rule of this world. Yeah.